Hello, everybody. I am Aisha Khatun, a data analyst for the search team at Wikimedia Foundation. And happy birthday to Wikidata. It's been 9 years already. For this presentation, I have done a little bit of work on Wikidata itself to try to analyze what it is composed of. This work is a byproduct of our effort to try to help scale the service, the Wikidata query service, and for that, we've been looking into what Wikidata consists of, what are the various queries that comes into Wikidata so that we can efficiently scale it. As a part of that project, what I did was create a nice little graph of some of the top subgraphs in Wikidata. G is available in the link here. So we can move on to the link itself. So this contains a top 50 subgraphs of Wikidata. If we look into what it contains, this page might take a little bit long to render because it's a large graph, although it's not the entire Wikidata. So it contains the top 50 subgraphs of Wikidata, and by subgraph we mean everything that is instance of something. So in this instance, we can see that the largest subgraph in Wikidata, and I believe it is already known a lot, is scholarly articles. So if we click on it, we will be able to go into the Wikidata item of scholarly article. We will be looking into what rank it is. It's the largest subgraph. It has almost 6.5 billion triples, which is almost 50% of Wikidata. And there are some other information in here, such as the number of items in this subgraph, the number of predicates used in this subgraph, the number of out degree, which is the number of connections this subgraph has with other subgraphs, then the number of connections other subgraphs have with this particular subgraph, which is in degree, and the number of connection it has to itself, which is self loop. Well, most of this information may not be very relevant to most people. It's very it's quite cool to just look into what Wikidata is composed of and just play around with this graph. So we can look into some other subgraphs, for example, astronomical objects, which is also quite well known. It is the second largest subgraph, composed of almost 9% of all Wikipedia triples. And there are other things like biographical articles, which is 44, etc. We can also look into the edges, and the edges represent the connection from one subgraph to another. And if you click on it or hover over it, we will be able to see some information. This edge represents triples that connect scholarly article subgraph to the human subgraph. There are this many triples, and then vice versa, opposite direction, we have that many triples. And there are some items that are instance of both human and scholarly article, which is a bit weird. I mean, which article is also a human? So yeah, the edge weight. So every edge here is a bit bold or a bit thinner based on its weight. And the weight is given based on a couple of things. It is given based on the number of connections from one edge to another, one subgraph to another, the number of common items both the subgraphs have, and the number of common predicates both the subgraph use. Although there are some weights given to each of these components. For example, if two subgraphs have lots of common items, the connection between them will be quite heavier. So we can move this graph around to look into this instance with a heavy edge. This is the one. So this instance is protein and gene. They have 12 common items and a lot of connecting triples. Again, we can move around and look at, oh, okay. What is this? Oh, it's mountain and hill. So there's a lot of connection between mountain and hill as well. There are a lot of common items, and it's quite understandable they are similar. So this is something we can play around and look into to understand what Wikidata is really composed of. This graph is interactive, so we can move things around and see it for ourselves. But since it's quite heavy, it might take some time to reload and to adjust and get back to its shape. But yeah, feel free to look around. Thank you. Bye.